Okay, so section 11.10 is solving what we refer to as radical equations, which are not just amazing equations, but rather equations that include your variable inside a radical. If we've talked before about equations like this, where you have an equation like 4x plus equals 12, that's your most basic equation. To do it, you undo your multiplication by dividing both sides by 4 or multiplying by the reciprocal of 1/4. We've talked about equations like this. We've got x squared equals 4, which you solve this by undoing the square, which is taking the square root of both sides. And so you get x equals 2. Well, radical equations, 2 and negative 2, are when you have something like this, where you have the square root of x equals something. And you need to figure out what that value of x is. Well, you do it by undoing the square root. Well, you undo the square root in the same way that we undid, or the opposite way that we undid the square, and that is by squaring both sides. And so the first thing that you do when you're dealing with radical equations is you square both sides. Now, these get more complicated, and there's some things that you have to do first, but your basic idea is you square both sides. And so the square root of x squared just turns out to be square root of x times square root of x, which is square root of x squared, which is just x. That's what this equals. The square root of x squared is x. And then 4 squared is 16. So the solution to that equation is 16. So we're just going to apply that idea to some examples. So your first example would be one like this, where you've got the square root of 2x plus 3 equals 7. It's a radical equation. Our variable is underneath our square root. So we have to ask ourselves, how do we get rid of that square root so that we can get the x, the variable, isolated by itself? And we do that by squaring both sides. Remember what I talked about here. This is your basic idea of radical equations, which is the square of a square root just equals whatever is inside the square root. So the square root of 2x plus 3, quantity squared, just equals 2x plus 3. And then don't forget to actually square this other side. That is a common mistake, that you forget to square the other side. So you get 2x plus 3 equals 49, and then you just solve it like you normally would to get 2x equals 46, so x equals 23. And then the next one, another example. Now, one thing that you always want to do is you always want to substitute it back in and make sure your answer works. You will get what we call extraneous solutions in these problems. And we'll talk more about those later in just a little bit. An extraneous solution is a solution that comes out of the algorithm, but is actually not a solution to the equation. All right, so another one would be one like this. 4x minus 3 equals 17. Again, square both sides. One thing you'll notice is that your answers can get pretty big pretty fast, because when I do 4x minus 3, the square root of 4x minus 3 squared, you get 4x minus 3, but then you have 17 squared. That equals 289. And so now we've got 4x equals 292. So that means x equals 73. We substitute 73 back into that. That equals 292 minus 3, which gives you 289. The square root of 289 does equal 17. So we know that 73 is the answer to our equation. Another variation on things that you need to make sure you're comfortable with. If you've got a fraction, that doesn't need to change anything. You could do some other thing with it, but if you've just got an entire fraction inside a square root, then you can just square both sides. And then the other thing is, you do need to know how to, when we square both sides, how do I handle this? So the first one, this is easy, right? The square root of something squared just equals that something. So 2x minus 1 over 4. The square root of 2x minus 1 over 4 squared is just 2x minus 1 over 4. And then 5 root 2 squared. Well, you got to think about how you handle that. And 5 root 2 squared is just going to be the same as 5 root 2 times 5 root 2, which gives you 25 times the square root of 4, which is the same as 25 times 2, which is 50. And so then we can solve from there, and you get 2x minus 1 equals 200. Add 1 to both sides, we get 2x equals 201. So x just turns out to be 100.5. If I plug in 100.5 over here, I get 201 minus 1, which equals 200. 200 over 4 is 50. Square root of 50 equals 5 root 2. You can have them like this, where you have an x squared underneath the, and so let's do it like this. You have an x squared underneath your square root. Notice this one's a little bit different. The reason why squaring both sides works nicely on a problem is because the square root is isolated. So for this problem, you don't want to square both sides until you can isolate your square root. And so the first thing that you should, my bad, this problem was plus 2. The first thing you're going to do is subtract 2 from both sides, and that's going to give you the square root of 4x squared plus 13 equals 3. When you square both sides, you get 4x squared plus 13 equals 9. So now we run into a problem, because when we subtract 13, we get 4x squared equals negative 4, which means x squared equals negative 1. Well, right now, we haven't learned any way to solve this equation, so this problem just turns out to be no solution or no real solution. There's no real number squared that equals negative 1, because you can't take the square root of a negative 1, so you can get a no solution to these types of problems. And then the last one is our example of what we call an extraneous solution. If we have 5x squared minus 16 equals 9x squared, or not 9x squared, it's 3x, sorry. Again, we have a radical that is isolated, and so we're going to square both sides to get rid of that radical. So that's going to give me 5x squared minus 16 on this side. I should be plus 16, sorry. Problem down wrong. And so then this side, you're going to have 3x squared, 3x times 3x just equals 9x squared. Well, now we get this equation. To solve this equation, we need to solve for the x squared. So we're going to get 16 equals 4x squared, which means that you're going to have 4 equals x squared. And so when you take the square root of both sides, that gives me x equals plus or minus 2. However, if you come back up here, when you plug those in, if you plug in 2, you get the square root of 5 times 4 plus 16. And then over here, you're going to have 3 times 2, which equals 6. Well, yeah, that's true. Square root of 36 does equal 6. But if you plug in the negative 2, you get the same thing on the left side, right? You get a positive square root of 36 on the left, but on the right side, you put in the negative 2, you get a negative 6. That does not work. So 2, yes, it is a solution because 6 equals 6. But when you put a negative 2, remember the square root is inserted for you. So we're talking about the principal square root or the positive square root. So when we plug in negative 2 here and get negative 2 squared is 4 and get 6 on the left, but we get negative 6 on the right. So negative 2 is not a solution. So the answer for this one is just x equals